Hey guys, in this first video of Unit Circle Day 1, we're going to be talking about the first quadrant of the unit circle. So, quick reminders, unit circle has a radius of 1 and the center of the circle is at the origin 0, 0. Coordinate points. So if it's on a coordinate plane, they're going to be coordinate points which are on the edge of the circle. Coordinate points on the unit circle so remember it's x comma y. Now x is represented by cosine of theta. So the x distance is the same as cosine theta. The y distance is the same as sine of theta. So this is y, cosine is x. Now, quadrant 1. If you know quadrant 1, you know the whole unit circle. That's really, really important. You'll see why shortly. Okay, so quadrant 1 of the unit circle, let's draw it out. So our coordinate plane is going to keep going past this, but we're just going to focus on the first quadrant. So here's our circle. That's pretty good. So there are 3 angles, really. Well, I guess 1, 2, 3, 4, 5. I guess 5 technically. So we've got 0 degrees, oops, or 0 pi. Then we have 30 degrees, or pi over 6. Then we have 45 degrees, or pi over 4. Then we have 60 degrees, or pi over 3. Then we have 90 degrees, or pi over 2 radians. So there are all of the angles, their degree and radian measures for just the first quadrant. Now, those coordinate points I was telling you about. So each of these are going to be a coordinate point, x comma y, or cosine comma sine. So what are they? Where do they come from? Well, they come from turning each of these into a right triangle. So let's pull those out. So starting with the 30-degree angle, or pi over 6. So for 30 degrees, if I pull that out, I've got a right triangle, and this is 30 degrees. The hypotenuse's length, we all know, because this is a circle, and the radius of the unit circle is 1. So I'm going to label my hypotenuse as 1. Now, the horizontal distance, that's x. So I know that this is going to be x. And that vertical distance here is going to be y. And now it's just a special right triangle. So I know that the side across from 30 is a, the side across from 60 is a root 3, and across from 90 is 2a. So all of that being said, I can use my special right triangle and figure out that a has to be 1/2. So I know y is equal to 1/2 when my angle is 30 degrees. And then x is a root 3, so I know x is going to be equal to 1/2 times root 3, which we can rewrite as root 3 over 2. So that means that the coordinate point at 30 degrees is going to be root 3 over 2, comma 1/2. Now let's try 45 degrees. So if I pull out my 45-degree angle, or pi over 4, turn it into this right triangle. Again, the hypotenuse is 1. This distance is still x. This distance is y, but it's just for a different kind of triangle. Because it's a 45, 45, 90 triangle, I know that this is equal to a, x is equal to a, and the hypotenuse is a root 2. So that being said, solving for x or y doesn't really matter. I can start by just saying, you know what? If 1 equals a root 2, 1 over root 2 equals a, and we need to rationalize the denominator. I'm sorry I'm going fast, I just don't want to run out of time. So if I rationalize the denominator, I end up with root 2 over root 4, which simplifies to 2. So that means that my x distance is equal to root 2 over 2, and my y distance is also equal to root 2 over 2. So then those are my coordinate points. Now just kind of recapping, what that means is cosine of 45 is root 2 over 2, and sine of 45 is root 2 over 2. Okay. Last angle is 60 degrees. So if we turn this into a right triangle, keep making these so tiny. There we go. Whatever. 60 degrees here. Again, my hypotenuse is 1. This distance is horizontal distance, which is x. This distance is vertical distance, which is y. And then x is now a, and y is now a root 3. And hypotenuse is still 2a. And now we've already done the work for this, so hopefully you realize, well, x is going to then be 1/2. And if x is 1/2, then y is going to be root 3 over 2. So now we've got all the coordinates for, well, almost all of them. So all of these coordinates in the first quadrant stem from these right triangles, these special right triangles out of the unit circle. So let's redraw that first quadrant, because we need to make sure we got it good. So I've got a unit circle. Here is 0 degrees, or 0 pi. Then I've got 30 degrees, or pi over 6. Then, I forget what color I used, pink? we've got 45 degrees, or pi over 4, then 60 degrees, or pi over 3, then 90 degrees, and in radians, pi over 2. So what are the coordinates? Well, the coordinates over here at 0 degrees or 0 pi, well, what's my x distance? It's 1. And what's my y distance? 0. And then we just went over this. So my x distance at 30 degrees is root 3 over 2. The y value, 1/2. At 45 degrees, root 2 over 2. And y is also root 2 over 2. So 45 is kind of easy. Then, at 60 degrees, x is 1/2, and y is root 3 over 2. At 90 or pi over 2, x is 0 because we're at the origin, and y, because the radius is 1, is 1. So that's the first quadrant, and what that allows us to do is figure out the rest, which we'll talk about in a second, because of our reference angles. And then it also lets us be able to calculate sine and cosine. So if I said, what is sine? Here, we'll do an example. If I said, what is sine of 60 degrees? Okay, what you're going to do is you're going to think, okay, what is the y value at 60 degrees on the unit circle? And you should know your unit circle. Maybe not just yet, but you will. And the y value at 60 degrees is root 3 over 2. So sine of 60 is root 3 over 2. Now I could ask you, what's cosine of pi over 4? So now you're thinking, what is the x value at pi over 4? And that is going to be root 2 over 2. So you kind of do need to memorize these coordinate points, or at least these ones, but where they all come from are special right triangles. Now in the next video, we'll talk about the entire unit circle and how to remember that this is pi over 6, pi over 4, pi over 3.